Yeah, that's like a problem 7 here. The cable is connected 6 meters from the left side. It's a 10-meter long beam. Okay. So this is 6 meters here, right? So let's draw a picture of all the forces. Okay, I'm going to say that the force of the wall in the y direction, right, is that way. Force of the wall in the x direction is there. We've got the force of gravity acting straight down on the beam, and this acts at the center of the beam, right? So this is 11 times 9.8. That's what I mean by the G. Okay, 11 times 9.8, and then it's a 10-meter long beam, so that would be at the center would be 5 meters from the left side. So from the left side. All right, and then the tension of this thing, let's see if we can draw this without failing too badly. All right. Okay, I think I failed. But anyway, we'll call that T for the tension, right? And this is 39 degrees right here. So this guy has two components. It's got a horizontal component here that you are struggling to see against that black background. It's got a vertical component, right? The vertical component is T sine theta. Is the vertical component. And then the horizontal component is T cos theta. Okay. And I'm getting this from SOHCAHTOA. So if the hypotenuse is T, the vertical component here is T sine because it's the opposite side. And the horizontal is T cos because it's the adjacent side, right? And then we've got a force out here of 8 times 9.8, so 8G, and then that is all the way at 10 meters, right? All right. And, okay. So what we're going to do is we're going to set up an X expression. My X expression is, what is it? Well, I think these are always simple, right? The wall in the X direction minus this component right here. So minus T cos theta. And it's 39 is theta, right? Of course, we can't solve this. What we're going to do is figure out T and then plug it in, right? And then we're going to set up a Y expression. Okay, in the Y direction, we've got the wall in the Y direction. We've got the force of gravity down, 11 times 9.81, right? That's what I mean by that. That's 9.81. All right, let's see. And then we've got the tension upward, and it's this part of it that's upward. It's only T sine theta that's upward, right? So plus T sine theta, and theta is 39, right? It's a 39. So hard to see. All right, that is up, and then we've also got the weight of this guy down. So minus 8 times G, and then that's 0. Okay. So those are our equations, right? And then we can set up torque, right? And the torque one is going to be the one that's solvable, right? So let's set up our torque. And I'm going to torque about the left side. About the left side. About. I must be Canadian. I keep forgetting the U in about side. Sidu. All right, so about the left side, I've got 0 times the wall's force in the Y direction. Remember, the X direction of the wall's force doesn't do torque because it's parallel to the beam, right? Okay, and then we've got a positive torque of this guy, the force of gravity acting at the center of mass, right? So plus 5 meters, and it's 5 because it's at the center. The beam is 10 meters long. So the center of gravity would be 5 from the left side. So 5 times 11G. Right, and then this guy would be anti-clockwise, right? So minus, and where is that attached? The cable is attached 6 meters from the left side. So minus 6 times T sine theta. I keep saying theta. I need to say 39, right? Okay, there we go. Minus T sine 39. And then we've got another positive torque about the left side, and that's this guy here, right? So plus, How far out is that? That's all the way out of the end. So that's 10 meters times 8g. And then that, of course, is 0. All the torques add up to 0. Now, because I picked a spot where one of the unknown forces acted, right, I can cancel that out, right? You can make these a lot harder. You could torque about the center of the beam every time, and then you'll have to set up matrices or something like that to solve it. This is my trick. It's everyone's trick, but I'll claim as much credit as I possibly can. Okay, so this is now solvable for t. So I'm going to just do some maths here. Let me go 5 times 11 times 9.81 plus 10 times 8 times 9.81. Get that answer. Now I'm going to divide by 6. Divide by sine of 39. And I get 350.7. Okay, so my tension is all right. Tensions are always positive. It's very hard to push with a cable, right? And now we can plug this into here, right? So look at that. What did it do? I thought I had the. Okay, so let's just plug this in. So wall in the y direction minus 11 times g times 9.81, right? Plus, and then the tension is this, right? So I'll plug that in, 350.73 sine 39 minus 8 times 9.8 is 0. So now I can solve for the y direction, right? The wall in the y direction. This takes some maths. Okay, it's going to be, I think, 11 times 9.81 plus 8 times 9.81 minus that guy, the 370. I'm just grabbing that number times sine of 39. Minus 34.335. So wall in the y direction is minus 34.335. So it's 34.3 newtons down. You need to be able to say it like that. Okay, I'm not sure I'm going to be giving all full credit for just a minus sign, but maybe I will. Maybe I'll be so overjoyed if you can just solve one of these problems, right? All right, and then now we can set up our x expression, right? Okay, so x, whoops. So our x expression is wall in the x direction minus, and then t is 350.73 cos 39 equals 0. Okay, so grab that number times cos 39. Here we go. 272.6. So the wall in the x direction is newtons, so that's 273 newtons to the right. Ta-da! Yay! All right. So again, you figure out where all the forces are, right? Okay. Figure out what they are, and then just set up your x, your y, and your torque. Solve the torque one. Usually you can solve that because you can set up, there's only 2 unknown forces, right? So you set up the pivot point to be where one of the forces acts, and then you get an equation with 1 unknown, and then just solve it.